Hello and welcome to a quick lesson on systems of equations, how to solve them using the elimination method. Well, the elimination method is basically what it sounds like. You're going to eliminate different parts of information to find what you need to solve for systems of equations. Now, your second question is, well, what's a system of equations? A system of equations is a system of two or more equations where they all form a line. Now, here I have two equations, right? I know that these are basically the equations to different lines. I don't know what those lines look like, but I know that these are the equations to lines. My job is to find out where these lines intersect, because somewhere on the coordinate plane, I am being told that these two lines intersect, and my job is to find that point of intersection. The only trick is, you're not allowed to use drawings. You have to do it algebraically. Good news is, we actually can do it. So if we're looking for that missing coordinate, that xy, the answer, we need to go ahead and line these two equations up. I'll show you why in a second. So take the two equations that you have, So the first one is minus 3x minus 2y equals 0. Put that one on top and we'll put the other one underneath. So you have 4x plus 2y equals 0. Oh, sorry, not 0, equals 4. Okay, now, what I want you to do is pretend that you're in elementary school. Pretend that you're all the way back in elementary school, and this difficult problem is actually just a simple piece of addition. You have two numbers and you're adding them together. Now your first reaction is, there is no way that this is simple. How can I just add these together? Well, think about it. You have like terms in these equations. You have a coefficient with an x here. You have a coefficient with an x there. Here, you got a number and a y. Okay, well, you got a number and a y here as well. And then, finally, you have a number by itself and you have a number by itself. Just go ahead and add these up, top to bottom. Okay, so here I have negative 3 and then 4. Well, that's a positive 4, so negative 3 plus 4 is 1, which just gives me x. All right, perfect. And then here I have negative 2y plus 2y. Okay, perfect. Well, those two are opposites, so they're pretty much going to cancel out. I'm left with 0y, which is the same as 0. So 1x plus 0 equals 0 plus 4, 4. Okay, well I know that 1x is basically x. I know that my 0 doesn't matter, and then I'm left with 4. Ta-da! I have an answer. Or do I? I'm nearly there, but I'm not there yet. I just found out that x equals 4, and that's fantastic. But if you want to find that coordinate where these two lines intersect, you need more than just an x. You need a y. So now all you're going to go ahead and do is take that x value, choose either one of the original equations. It doesn't matter which one. It really doesn't. Choose either one of those two original equations, and you are going to go ahead and plug in the x value into them. Okay? So let's say we choose the equation on the left. And if you want to know why I'm choosing it, the numbers, I don't know. They look smaller to me. They look easier. So I'm just going with it. So I have negative 3x minus 2y equals 0. Okay. Now, there's a 4 that I need to replace for x. So I'm going to replace x with 4. And then everything else stays the same. Okay, so negative 3 times 4 is negative 12. Minus 2y equals 0. Now here, I just treat this like a regular equation, and my only job is to solve for that y. So let me go ahead and start getting rid of stuff on the side of the y, so I know what it's equal to. Well, let me get rid of the minus 12 first. The opposite of minus 12 is plus 12, so I'm going to go ahead and add 12 to both sides. On the left, that cancels out, leaving me with negative 2y equals 0 plus 12 is 12. Now again, I'm still not done. I want my y to be alone. It currently is being multiplied by negative 2. The opposite of multiplying by negative 2 is dividing by negative 2. So I'm going to divide both sides by negative 2. That cancels out, and I'm left with y. So basically, 12 divided by negative 2 is negative 6. There's my solution. Y equals negative 6. And since I have an x and I have my y, I have my coordinate pair. The answer is 4, negative 6. Now, you're going to notice the steps here are really easy. Line up top and bottom the two equations, add them up so you can cancel out opposite pairs, and then you're left with either an equation and you solve for the remaining variable, or it's going to be a simple question like the one I give you here, and it's going to be a simple one where the variable just presents itself, and you go ahead to the other equation, plug it in, and you get the other variable. Now yes, I know, this is a simple equation that I gave you. What happens when it's harder? What happens when there aren't opposite pairs that you can just go ahead and cancel out? What happens when it's not so obvious? Well, on to the next question then. Here, let's line up the equations again. So, here I have minus 4x plus 6y equals 52. And then I have minus 2x plus 7y equals 42. There's just one big problem here. I don't have opposites that are going to cancel out. Well, I still can do something here. I know that, let's look at my x's. I don't really see a relationship between my y's. I don't see a relationship between 6 and 7 that's going to be simple. So let me look at my x's. I know that there's a relationship here. I know that basically if I take that negative 2 and I multiply it by negative 2, I'm going to have 4. So negative 2 times negative 2 is 4, and the perfect thing about 4 is it's an opposite. 4 is an opposite to negative 4. So if only I had a 4 on that bottom equation, man, I could solve this whole thing. Well, hold on. Why didn't I do just that? Let me just multiply negative 2 times negative 2, and I get my 4. Now, of course, it's an equation. So if I'm multiplying any part of it by negative 2, I have to multiply all of it by negative 2. So let me just rewrite that. Okay, so I have negative 2 times negative 2 is 4x. 7y times negative 2 is negative 14y. And then 42 times negative 2 is negative 84. Perfect. Now let me just go ahead and take that initial equation I had up here, the one that I haven't touched, and I'm going to write it out below. So I have minus 4x plus 6y equals 52. Now, if I treat these like a big addition problem, things start to make sense. 4x minus 4x, well, these cancel out. Then I have negative 14 plus 6y, that becomes negative 8y. And now I have negative 84 plus 52. So all I have to do is work that out, and it will give me negative 32. Don't forget that's a plus there. Okay, so negative 32. Now I'm nearly done. My y isn't alone. It has a negative 8 next to it. To get rid of it, I divide by negative 8. If I do it to one side, I do it to the other side, divide by negative 8. These cancel out, and I am left with y equals negative 32 divided by negative 8 gives me 4. Y equals 4. Perfect. Now I'm nearly done, but not quite. I solved one variable. I need to plug into either of the original equations to go ahead and solve for the remaining variable, for the x. I'm going to choose the equation here on the right because it's got smaller numbers, and I like to make things easy for myself. So I'm going to go ahead and rewrite that equation. Negative 2x plus 7y equals 42. And then I'm going to plug in 4, the value I just found for y. Okay? So that's going to be negative 2x plus 7 times 4 equals 42. Negative 2x, well, 7 times 4 is 28, equals 42. I want to solve this equation now. Alright, let me start by getting rid of that 28. So I'm going to subtract 28 on one side, have to do the exact same thing on the other side, and I'm left with negative 2x equals 14. Okay, now I'm nearly done, but not quite. I still have a negative 2 next to the x, so to get rid of it, I'm going to divide by negative 2, and on the other side, I'll also divide by negative 2. On the left, the negative 2 divided by negative 2 cancels out, and I'm left with x equals 14 divided by negative 2 is negative 7. And boom, that's it. I have my solution for this system of equations. The solution, your xy value, is negative 7, 4.